Hello, everyone. What I want to do now is go over quiz 4. The scores were a little lower than usual. The average, I believe, was like a B minus, maybe C plus, and the median, the average was a C, and I think the median was a B minus, something like that. And these are important questions, definitely exam worthy, similar to the homework. But Anyway, right. So the first problem, Christine makes deposits of X at the end of each month into an account earning nominal monthly interest, I-12.09. These start June 30th, and the last deposit is May 31st. So this accumulated value of all these deposits are used to purchase an annuity immediate, uh, monthly payments of 600, interest rate I-12.06. Payments start June 30th and end May 31st. Find X. So first of all, if you think about it, when we have something like this, the deposits start on June 30th. It's probably best to think that the payment periods. We're thinking of deposits as payments, like we always do for an annuity. Um, the payment periods start at the beginning of June 1st, so that um, we're making deposits at the end of each month. And if you think in terms of the payment periods really start at the beginning of June, then we have 10 full year payment periods, which it means 120 payment periods, 10 times 12. Okay. So let's first actually figure out how much we need at the end of the 10 years. Well, how much do we need? Well, we need the present value of the annuity purchase. That's always the price of an annuity. The price of an annuity is always the present value. And again, I have said this multiple times. You might find that stupid. You might find that silly. That's just the way annuities work. That's the way loans work. It's just the way they work. All right. So let's figure out the annuity price. As I mentioned, the annuity price is just the present value. So the present value at May 31st, 2015. And that's for this annuity. Okay. Well, yeah, basically same as up here. The payment periods start, June 1st, May 31st. That's really basically the same thing. So we really don't make a distinction between the very end of a month and the very beginning of a month. It's almost getting philosophical, making the distinction between that. Right. So the point is, we have 5 full payment years. So that means 5 times 60 is 60 payments. So the actual monthly interest rate, J, it's, well, I-12 over 12. And that's 0.00, 0.005. I'm gonna make sure I got number of zeros correct. 0.06 over 12 is 0.005. So the actual PV is just simply going to be, well, I'm not writing it down, but payments P are 600, so it's P 600, A 60 times A60J, 0.005. And right, this is going to be 600. 1 minus 1.005 to the minus 60 over 0.005. And this is going to be 31,035, 33645. So roughly 34 cents. So this is the purchase price for my annuity. This is how much I need on May 31st, 2015 to purchase the annuity that Christine wants to purchase. Okay. Well, how do I accumulate to this much? Well, let's see. Let's see how. So going back to the deposits that are used to accumulate and to purchase this annuity starting on May 31st, 2015. As I said, there's 120 of these deposits. Okay, so the accumulated value on May 30th, May 31st. And I apologize for that stupid mistake. So easy to get little silly things like dates screwed up, and not a huge deal. But anyway, sorry, May 31st, 2015. Okay. Well, right. So N is 120. There's 120 deposits. Interest, the per month interest is I-12 over 12. So J is going to be 0.09 over 12. Right. So it's 0.0075. So the accumulated value is, well, we don't know what the deposits are. They're X, S120.0075. And that is going to be X times 1.005 to the 120. That's not 1.005, 1.0075. Sorry about that. Minus 1 over 0.0075. Now, of course, by now you've probably seen the video on using your calculator to do to very quickly compute any kind of annuity present or accumulated value, and that's absolutely fine to do. I do want to at least see writing down, not this formula here, but at least writing things like this, or I want to see you writing things like this down, or writing things like this down. Particularly if you don't write anything down and you get the answer wrong, I cannot give you a whole heck of a lot of credit, obviously. So anyway, so this is, what is this? 193.51428x. All right, so this amount is used to purchase an annuity that costs this amount. So the two have to be equal. So 193.51428. X is 31,035 and roughly 34 cents. So X is going to be 160.38. So these are the deposits you make at the end of each month. Okay. Yeah, so like I said, this is a good problem. I write the exam, so when I say something's a good problem, it might be on future exams. You probably should listen to that. Because it's not just plug and chug. You have to think a little bit. So, all right. So for the next problem, so we have a 30-year annuity, and I don't know if I made this clear. If I didn't, then I'm absolutely making this clear now. When I say a 30-year annuity, it's implied that we have yearly payments. Okay. Yeah. So right, if I yeah. So anything else, I'll say monthly payments, weekly payments, whatever. But if I do say a 30-year annuity, then it's implied that payments are yearly. Okay, so now that we have that out of the way, 30-year annuity, immediate makes payments of 100 for the first 20 years. So let's draw a time diagram. Definitely time diagram helps a lot here. And this is also a good problem. So let me just go through it before I say anything else. Got a lot of kind of funky answers for this problem. 20. Okay, so first 20 years, payments are 100. It's annuity immediate, so payments are at the end of each year. Interest is 4% for the first 10 years. Effective annual interest, so there's no nominal interest computations to be done. Okay. It's 5% for the next 10 years. And for the last 10 years, actually, sorry, payments for the last 10 years are 150. So this is 6%. Okay. So what we're going to have to do is, as we did in the videos and in the homework, is we're going to have to break this up because we have 3 separate interest rates here, in addition to 2 separate payments. Well, we're going to have to break this up into 3 different annuities. You always break the annuities up into separate annuities when you have a differing interest rate or a differing payment. Okay, and whenever you have that, where the difference, where things change, the annuity payment or the interest rate, that's where you break things up. So we're going to break things up at year 10, meaning we're going to look at the present value of this annuity here. We're going to look at the present value of this annuity here. I should put the dots to indicate. Anyway, and we're going to look at this annuity here. Okay, so let's look at the first. So I don't know. Let's say. Let's just look at this first 100 here. So this first one here is going to be 100. Well, nothing really too strange or confusing here. You have 10 payments. Payments are at the end of each month. Effective annual interest is 4%. So it's 10810.04. Okay, so that's fine. Now for this annuity, the payment periods begin at t equals 10, because it's an annuity immediate, and that's the way annuity immediates work. So the present value is going to be 100. Well, it's 5% interest, still 10 payments. Okay, but we got to be careful. This is present value at t equals 10. When I say present value, I mean present value. Everything has to be dated at the beginning, at the very beginning. Everything has to be discounted to the very beginning. Okay. If you're an accountant and you don't do this, your client is going to be really pissed off, because they're going to, they're probably going to possibly owe more than they really should be paying in taxes. Or it's just it'd be a grotesque accounting error if you don't actually do this. And as we talked about before, very briefly, that is, this is actually how you deal with accounting liabilities. Particularly liabilities. You discount everything to the current time, because that's the value of your liability. So this would be very relevant if you are particularly paying out this annuity and you want to know, well, what's my liability right now? Okay. So yeah, this has to be discounted, and interest from 0 to 10 is 4%. So we have to discount this using the 4% interest rate, 1.04. Okay. Now let's do the similar thing for the last annuity. I'm not going to try and fit it here, so I'll just go do it right here. So it's 150. Interest is 6%. So so again, it's a 10-year annuity immediate. When we take the present value using the formula, it's simply, that gives us a present value at t equals 20. So it's a 10.06. Okay, whatever that is. But that's the present value at t equals 20. We want the present value discounted discounted by 20 years to get it at the beginning of everything at t equals 0. So we have two different interest rates here. We have to discount 10 years using 5% and then 10 years using 4%. And that was pretty harsh if people didn't even bother to discount anything. If they forgot this 1.04 to the minus 10 and forgot the 1.05 to the minus 10, that's taking the present value of this 150 annuity from t equals 20 to t equals 10. Now we have to go from t equals 10 to t equals 0. Discount it again by 10 years. Yeah, so if you forgot this completely, I was pretty harsh, because that's kind of the point of this course, is being very mindful of the force of interest, and discounting things properly. But anyway, all right, so you add all this up. This becomes 811.09, 521.65. So yeah, if you see this on an exam, now hopefully you will not make the same mistake. Not a big deal if you made a mistake here and you recognize it. So it's 179062. Certainly, if you're a business person, you might want to buy annuities, you might want to buy bonds, you might even deal with loans. This is important to understand, because you do not want to overpay if you're buying and selling loans, which, ethical issues aside, is a very standard business practice to buy people's debt and whatnot. I mean, that's obviously more complicated than this, because you have to take into account the risk that people are not going to even pay their loans. But anyway, that's for another day. But anyway, yeah. So a nice, a useful problem, in my opinion. Um, all right. Any questions on this? As usual, let me know. Um, so long. Take care. Good luck on the quiz Friday.